No, no, I've had this problem with it depends.
I simply see a black screen, and at the bottom it says it gives me the time of the screen, and then it says Chiltern underscore HD4.
All right, he's across HD4, is he?
Yeah, well, that's what came up for me on you.
Yeah.
I was using it for VC only this morning, but not with you. So something.
He'll be interested to watch the recording of this back.
Yeah.
It's always amusing watching the recordings. No, sorry.
No pressure.
Yeah. He's gone now.
Okay, so what device is it, your printer, Alex?
So, it is part of the family of RepRap, or replicating rapid prototyping devices, which is started by, I think, a chap called Adrian Bowyer, and University of Bath were involved in this at some point. I don't have a potted history to hand, but it's an open source hardware project. I happen to be a member of the Thames Valley RepRap user group, which is sort of loosely modelled on a Linux user group, and happens to benefit from a couple of real electronics and engineering experts. So the particular 3D printer I have has some modifications and enhancements that are unique to the group, but in the way of open source hardware, they're quite available. They've been published, and you can build your own if you so choose. You can do that with bits of 3D printer that I could print out and send to you. So, for example, this.
Can print its own parts. Isn't that amazing?
Not only print its own parts, but it's for rapid prototyping. This corresponds to 3 plastic parts here, redesigned into one, which is uses a little bit less plastic and is a little bit more rigid, hopefully, in theory. But we can test it and find out. So to do that, I actually plan to build another 3D printer myself, which is going to be a little bit larger than this one. And when it's ready to go, I shall simply swap over the stepper motors into it and send it away. It's quite a simple computer numeric control CNC machine, and has X, Y, and Z axes, all built in reasonably appropriate materials. For example, this is a very standard domestic piece of mirror tile. This is plywood. This is threaded rod from that you can buy from B&Q. So the bill of materials that comes with it is an interesting piece of intellectual property, but the actual materials to build one of these are sort of hardware store items, which is quite fascinating. That's not the only kind of 3D printer you can buy, and I'm actually personally looking at going into a venture in Reading to sell and service 3D systems professional units, which are somewhat larger, and but based on the same principle of depositing plastic material. And the way it works is, I'll just tell you a little bit about the way it works and then get on with trying to make this demo work. This is all being cooked up completely in front of you, by the way. What it does is has an extruder, which is just very, very simply mechanically forcing into a small brass heating chamber a rather spaghetti-like piece of plastic, which happens to be PLA, or polylactic acid. Alternatives are things like ABS, from which Lego bricks are made. PLA has advantages, it's nice and rigid. Has disadvantages, it's rigid. If you want to use something which needs a bit more flexibility, then ABS is the way to go. It forces, but under a good deal of control with some very low gearing from the stepper motor, the filament into the hot end chamber using sort of micro step control. So it's very, very accurate. Much of the accuracy that's possible with one of these machines comes from very finely tuning the firmware and calibration. building one is easy. Calibrating it is a different story entirely. So, but fortunately, a lot of brighter people have been there before me, and I'm able to pick up on their experiences, add my own, and go from there. The brass hot end has a tiny little nozzle, 0.4 of a millimetre across, and essentially it gets no more complicated than that being raised to a temperature and kept there using a power resistor, and using a thermistor to send back to the control circuitry the temperature for a feedback loop to keep it locked to a temperature which suits the properties you want. So for good adhesion, you want reasonably hot plastic. For not sagging when you want to bridge a bit of a gap, you want it to be as cool as possible while still moving. So various factors to play about with. It then essentially draws a perimeter around the build area that you're expecting to work with, which is useful for calibration to check that something hasn't got out of alignment, and it's also useful to solve any overheating that might have happened in the build chamber in between prints. It sort of warms everything up, and then it basically gets to drawing a first layer perimeter and colouring it in. It doesn't get much more complicated than that, by repeatedly backwards and forwards moving across the build area. Then the lead screws raise it up a fraction of a millimetre. 0.3 is a sort of sensible level for a good quality and not a ridiculously long print. And you repeat the process. Rinse and repeat several hundred times, and you've got an object in front of you.
So are you going to try with the STL file we sent, or is this one
Yep.
that you... Yeah, okay, go.
I'll give it a go. So
I guess you have
I'm
to
just...
put that through some software to
I do.
Put it into the layers that it's going to deposit.
That's right. Paul, if we can hook my laptop screen up to the feed.
Yes. Yeah, I'll just share this in the content channel. There we go.
Okay, lovely. So this is